Hello. Hello students and welcome to this video. In this video, we will solve question number 181 to 190. So there are two things I'll say is that when I'm stating the problem, you should pause the video, and only if you cannot solve the problem, you should look at the solution. The second thing is that you can skip the question and come back later. Also, do not spend more than 15 minutes on a question. Now grab pen and paper and pay attention. The link to download the PDF will be in description of the video as well as the trigonometry books link, and at the end I'll show you how you can download the PDF. So without further ado, let's get started. Question 181 says that there are 5 questions in a question paper. In how many ways can a boy solve 1 or more questions? So the boy can solve 1 or 2 or 3 or 4 or 5 questions from the paper. So the total number of ways are 5C1 plus 5C2 plus 5C3 plus 5C4 plus 5C5. That is 31 ways total. Question 182 says that in an election for 3 seats, there are 6 candidates. A voter cannot vote for more than 3 candidates. In how many ways can he vote? So he can vote for 1 seat in 6C1 ways, for 2 seats in 6C2 ways, and for 3 seats in 6C3 ways. The total number of ways of voting are 6C1 plus 6C2 plus 6C3, that is 41. Question 183 says that in an election, the number of candidates is 1 more than the number of members to be elected. If a voter can vote in 30 different ways, find the number of candidates. A voter has to vote for at least 1 candidate. So there are n candidates, out of which n minus 1 have to be elected. Total number of ways in which this can be done is Cn1 plus Cn2 up to Ncn minus 1, which is given as 30. 2 to the power n is equal to 32 from this series. So you add NC0 and you add NCn, and that will be equal to 2 to the power n. So right hand side also you have to add plus 1 and plus 1 twice. So that will become 32. So n is equal to 5. So this question relies on the binomial theorem for the sum of NC0 plus NC1 plus NC2 up to NCn. Question 182 says that in how many ways 12 different books can be distributed equally among 4 persons? So for equal distributions, each will get 3 books. Number of ways to select 3 out of 12 is 12C3. Number of selections for 3 out of remaining 9 are 9C3 and so on. The total number of ways of distributing the books are 12C3 multiplied by 9C3 multiplied by 6C3 multiplied by 3C3. That is 12 factorial by 3 factorial to the power 4. Question 85 says that in how many ways 10 mangoes can be distributed among 4 persons if any person can get any number of mangoes? So we have 10 mangoes and 4 persons. We know that number of ways of distributing n identical things among r people, where any person can get any number of things, is n plus r minus 1 cr minus 1. Therefore, required number of ways are 13C3. Question 186 is that in how many words can be formed out of 10 consonants and 4 vowels such that each contains 3 consonants and 2 vowels? So 3 consonants can be selected out of 10 consonants in 10C3 ways. 2 vowels out of 4 can be selected in 4C2 ways. Now 5 alphabets can be arranged in 5 factorial ways. The total number of words that can be formed are 10C3 multiplied by 4C2 multiplied by 5 factorial. Question 187 says that a table has 7 seats, 4 being on one side facing the window and 3 being on the opposite side. In how many ways can 7 people be seated at the table if 3 people X, Y, Z must sit on the side facing the window? So we seat X, Y, Z on the side facing the window. Now from remaining 4, one has to sit on this side which is 4C one way of selection, and from the remaining 3, all 3 have to sit on the other side, which is 3C, 3 ways of selection. The total number of selections are 4. For each selection, the number of arrangements are 4 factorial multiplied by 3 factorial, because one side there will be 4 people, other side there will be 3 people. The total number of ways of seating are 4 factorial multiplied by 3 factorial multiplied by 4. That is 576. Question 188 says that a tea party is arranged for 16 people along 2 sides of a long table with 8 chairs on each side. 4 men wish to sit on a particular side and 2 on the other side. In how many ways can they be seated? So 6 men have preferences. Suppose on one side we seat 4 men who wish to sit together. Then to fill remaining 4 positions, we have to choose from 10, that is 10C4. Now for the remaining 6 seats, we have 6 people which can be seated in one way. Both sides can be arranged in 8 factorial ways. So number of ways of seating them is 10C4, 8 factorial multiplied by 8 factorial. Question 189 says that 8 chairs are numbered 1 to 8. 2 women and 3 men wish to occupy 1 chair each. First 2 women choose chairs among the chair marked 1 to 4, and then men select the chairs from the remaining. Find the possible number of arrangements. So, since 2 women are seated on seats number 1 to 4, the number of arrangements are 4P2, that is 12. Now 3 men are to be seated on 5 remaining chairs. The number of arrangements are 6P3. The total number of arrangements are 12 multiplied by 120, that is 1440. Question 190 says that show that 2NCR where R is less than equal to 2N is greatest when R is equal to N. So we consider 2NCR by 2NCR minus 1, which is equal to 2N minus R plus 1 by R, which has to be greater than 1 if 2NCR has to be greatest. So 2N minus R plus 1 greater than equal to R, that means R less than equal to N plus 1 by 2. Okay. Considering 2NCR by 2NCR plus 1, we find that R is greater than equal to N minus 1 by 2. So we combine the result, that is N minus half less than equal to R less than equal to N plus half, but R has to be an integer and thus R is equal to N. And with this, we come to the end of 19th set of problems. And let me show you how you can download the PDF. We go to my website astro.org and download algebra book from the second link and trigonometry book from the third link. I'm working on coordinate geometry book, and which should be available within 15-20 days. So keep practicing and do not wait for the video to be recorded. And if you have any questions or doubts, please make use of comment to ask questions. And you can ask questions from any mathematics book. It does not matter if the question is from my book or a different book, and I'll try to help you. Please make use of the comment box. So I hope that you are enjoying this series of videos and finding it useful. Thank you for watching the video, and I'll see you in the next one. Till then, I will take my leave and you keep practicing. Thank you.